Good morning, students. I hope you are all safe at home. In last class, we revised about the portions 8.1 and 8.2. Today, we are going to see about this chapter, Applied Statistics. In this chapter, we are going to see about the time series as well as about the need for studying time series, uses of time series, and what is the meaning of seasonal index, and also about irregular variation. Okay, so now we are going to see about the exercise 9.1. Okay, define time series. So when quantity data are arranged in the order of occurrence, the resulting series is called the time series. That is the data, that is the quantity data are arranged in the order of occurrence, means it is in ascending order or sometimes in descending orders. So that is called, the resulting series is called as time series. Okay, this is the concept regarding the time series. So what is the need for time series? Here some important objectives for the time series in order to find the time series is identify the variation and try to eliminate the variation, and also helps us to estimate the future values. In order to estimate the future value, as well as if any variation is occurred, in such a case we eliminate those variances. Okay, then some of the uses of time series are given here. It helps in analysis of the past behavior, that is we know about the past, as well as it helps the forecasting the future plans, and also the evolution of current achievement. Okay, so it is used for past, future, and as well as current achievement. It helps in making comparative studies between one time of period, that is past last year to current year or future year, like that it is we can compare here. Okay, then some of the components of time series are secular trend, seasonal variation, cyclic variation, and irregular variation. These are the some components, that is the methods we are using here in order to find the time series. Okay, so here what is meant by defined secular trends? The tendency of time series is to increase or decrease or stagnates, that is there is no change during a long period of time, is called secular trends. Okay, so in cricket also you are seeing the graph. Okay, it goes on according to the run rate. Sometimes it decrease, sometimes it increase, sometimes it is in stagnates. So according those tendency of the time series, increase or decrease or stagnates during a long period of time, is considered as a secular trend. Okay, then next about seasonal variation. Here the tendency movement of due to nature. Okay, it is due to nature that repeat themselves, which repeat themselves periodically in every season. For example, we say it as a rainy season. Okay, so in each and every years we come across some storms in raining seasons. Okay, so these variations repeat themselves in less than 1 year time, so it is measured in an interval of time. Okay, so in seasonal variation may be influenced by natural force, social custom, sometimes by way of tradition. Okay, then next one is cyclic variation. It is not necessarily uniformly periodic in nature. This may or may not exactly similar pattern after equal intervals of times. Generally, one cyclic period ranges from 7 to 9 years. Okay, it is not about within 1 year. So there is no hard and fast rule in the fixation of years for a cyclic period. Next, we are going to see about the sums related to this exercise. Before going to see the sums, we come across some formulas. Okay, so the straight line trend is represented by y equal to a plus x, and the constant a and b are constant. Okay, the next equation is solving the following two normal equations. There are two normal equations are, one is sigma y equal to n of a plus b of sigma x. Sigma is summation of x. Okay, summation of xy equal to a into summation of x plus b into sigma x square, where n is the number of years given in the data. Now we are substituting the value of a and b and get the line for best fit. Okay, this is the way we are, that is we are using these three equations in this chapter. Okay, then state the two normal equation, again the same things. Then state the different methods measured in trend, that is freehand or graphic method, method of semi-average, method of moving average, method of least square. In this exercise we are going to see about these four methods. Okay, first we are going to see about the sums one by one. Okay, so here the 13th sum. Compute the average seasonal movement for the following series. Here the years are given 2002, 2003, 2004 and 2005 and 6, whereas quarterly production is first two, that is quarterly means it is 3 months. So first 3 months, then 3 to 4 to 6 months, then third quarter and fourth quarter. Okay, so using this I am finding the value of average seasonal movement. Okay, listen, average seasonal movement. First we are finding the average value by taking the data as it is, that is a column as well as the row, and taking the average of the first quarter. Average of first quarter means how many years are there here? Nearly 6 years. Okay, 2002 to 2006, it is nearly 5 years. So add all those things, we are getting the total 18.6. so 18.6 is divided by 5, we are getting 3.72. that is the average of first quarter. Likewise, we are finding the average of second quarter by way of totaling that second quarter and divide it by 5, we are getting 4.16. That is the average of second quarter. Likewise, we are finding the average of third quarter by dividing it by 5, it is 3.76. Average of fourth quarter is 4.16. Okay, very simple to attend the sums like time series analysis. Okay, next we are going to see the 14th sum. The following figures relate to the profit of the commercial concern for 8 years. Okay, here the data are given like a horizontal, we are writing it as a vertical manner in order to find the values, find the trend of the profits by the method of 3 years moving average. Listen here, it is not an average method, it is 3-year moving average. In 3 years moving average, we write the year as well as profit in a vertical and find the 3 years, that is 3 years profit. For example, 86, 87, 88 profit are added. 15,420 plus 15,470 plus 15,520. We are getting 46,410. It is given in the middle of the year, that is 86 to 88. The 87 is the middle year. So okay, so we write in the middle of the year, 3 yearly moving average total is 46,410 by adding the first 3 years, that is 14,420, 15,420, 15,470, 15,520. We are getting 46,410. Likewise, after that we are taking the year 87, 88 and 89, omit the 86. Okay, so add 87, 88 and 89, we are getting the total 52,010. Then 88, 89, 90's profit are added, like for example 15,520, 21,020 and 26,500. We are getting 63,040. Likewise, we are omit 1 year and add the remaining 3 years. We get the 3-year moving total. After attending these 3 years, we divide it by 3 because it is a 3-year moving average. In order to find the average, it is a 3-year moving total. So in order to find the 3-yearly moving average, I am dividing it by 3. Okay, so after dividing it by 3, you are getting the answer like this: 15,470, 17,336, 21,013 and 26,490, 31,350 and 34,150. Okay, this is the way you do the sum. Very simple sum. First you add the 3 years profit, after that divide it by 3. Okay, moving average means you may go one by one. Okay, first take the first 3 year, next take the second year, third year and fourth year. After that third year, fourth year, fifth year. After that fourth year, fifth year, sixth year. After that fifth year, sixth year, seventh year. So you leave 1 year and add the remaining 3 years profit. After that divide it by 3, you are getting the 3 years moving average. Okay. Now next, find the trend of the production by the method of 5 years moving period. Here also we are doing the same method, but we are adding by 5 years. First add 5 years production, that is 1979 production, 80, 81, 82, 83 production. You are getting 619. After that add 80, 81, 82, 83, 84 production. Then goes to like this, you may go one by one. Okay, for getting the value like this, then divide it by 5 because it is a 5-year moving average. Okay, that's all. Okay, so moving average means it is very simple to get the answer. Now we are going to see the next sum. but it is a freehand method. Okay, trend value by the method of freehand. The following table gives the number of small scale units registered with the Directorate of Industries between 1985 to 1991. Show the growth of the trend line by the freehand method. Okay, so here the years are 1985 and 1986, 1987, 88, 89, 90, 91 and 92. Okay, write the years and as well as the number of units like this. Okay, so here is 1985, it is 155. Production intensity is very in some wait. So here they are asking that to find the trend value method. Okay, it is a freehand method. So you plot the values, that is for 1985 it is 10, for 1986 it is 22, for 1987 it is 36, like that you plot the values in the graph. Okay, after that you find the trend line. Okay, so this is the way you do the sums. Okay, then next one, the annual production of a commodity is given as below. Fit a straight line trend by the method of least square. This is the important method asked in 5-mark question. So here the years are given as well as production given, but they are asking fit a straight line trend by the method of least square. So we are using here some formulas here. First write the year as it is and production in tons, and the capital X is nothing but take the middle year. Here there are 7 years, so middle of the year is 1998. Okay, take the middle year as assumed mean. So X minus capital X equal to X minus 1988. For example, here small x represent 1995. So 1995 minus 1998 we are getting minus 3. Then 1996 minus 1998 we are getting minus 2. 1997 minus 1998 we are getting minus 1. 1988 minus 1998 means it is 0. So likewise we are finding the capital X value. After that, squaring this capital X, that is 3 square equal to 9 and 2 square equal to 4, you are taking the third column. So first find the capital X by way of subtracting the middle year from the X value and squaring the X, that is the fourth column. And fifth column is capital X into Y. Capital X is nothing but minus 3 minus 2, that is third column. Capital Y is nothing but the production intents. So multiply these things. So we find capital X square and capital XY. Okay, now apply the formula. Here sigma x equal to 0. Sigma x is nothing but summation of x, and summation of x square is 28. Summation of xy, that is you add all those things, you are getting 92. Okay, write the sigma x equal to 0 and summation of a equal to summation of y by n. This is the formula for finding a. Here y is 1186 divided by n is 7 years. We are getting 169.428. And as well as b equal to sigma xy divided by sigma x square. We are getting 92 by 28. It is 3.285. So after finding the a as well as b value, write the formula. The required equation of a straight line is straight line trend is given by y equal to a plus bx. The value of a equal to 69.428. That is a listen here, it is 169 or 69. Correct it, some mistake are there. So write it as 169.428 plus the value of b equal to 3.285, and capital X, we are taking the capital X is capital X is x minus 1998. Okay, then find the value of equation is y equal to 69.428 plus 3.285 x into 1998. After that we find in the trend value. Okay, then next sum. Determine the equation of a straight line. Determine the equation of a straight line. The year is given 2000, 2001, 2002, 2003 and 2004. Okay, so compute the trend value for all the years from 2000 to 2004. Okay, So the trend values are, here it is given that year equal to 2000, 2001, 2003 up to 2004. Sales also given. Here the mid value is middle year is 2002. Therefore take capital X equal to X minus 2002 and find the value of X square as well as XY, and apply the formula A equal to sigma Y by N and B equal to sigma XY by sigma X square. Okay. So this is if sigma X equal to 0, we apply this formula and finding the equation like this, y equal to a plus bx. Then we may find the trend value by giving the value of x equal to 2000, 2001, like that is the year 2002, 2004, like that. Okay. Then next one, the sales of a commodity, that is a 19th sum in tons, varied from January 2010 to 2010. 20 actually it is 10 to December 2010. Then year, month is given, the sales also given. Find trend line by the method of semi-average. Semi-average means we divide the year month into year into two equal parts, that is January to June, one average. We find the average for those things by dividing it by 6. Okay. And then from July to December we divide it by again 6 after the summation. So we are getting 2 points. So plot those 2 points in the graph and draw a line across it. Okay, you get the value of semi-average method. The next one is use the method of method of monthly average to find the monthly indices for the commodity for year 2002, 3, 4. Here they are asking about monthly integers. So write the year. Okay. So January month, February, as well as likewise you write all the month one by one up to December. Okay. Then find the grand average. For example, the monthly total is given as, for my January monthly you add the total, it is 53. February likewise you add up to December. Then monthly average means 53 divided by 3, that is 3 month. Okay. Then 61 divided by 3. Likewise you take the monthly average, and grand average is nothing but take the monthly average, that is summation of the monthly average divided by the number of months, that is 12 months. Okay, this is the way you find the value of monthly average, it is 17.3. After that seasonal trend, that is for January is, that is monthly average divided by grand average into 100. Likewise you find up to January, February, March, April up to December. Okay. So this is the way you are doing the sum for monthly averages. Then calculate the seasonal indices from the following data. Calculate the seasonal indices from the following data using the average from the following data using the average method. Here years are given and the quarterly, second quarter, third quarter and fourth quarters are given. Okay. So first find out the total of each quarter and finding the average of each quarter by way of dividing it by how many years are there here? 5 years. So if I divide it by 5, you are getting 74.4, 71.6, 72.4, 72.8. Okay. After dividing it, divide it by 4. After the summation, divided by 4, you are getting 72.8. Then seasonal index for first quarter is, average of first quarter is 74.4 divided by grand average, that is 72.8 into 100. So for 4 quarters you have to find the seasonal index. Okay. Then next one is the table shows the number of salesmen working for a certain concern, and use the method of least square, fit a straight line and estimate the number of salesmen in 1997. So here also we are finding capital X and X square as well as XY, because here summation of X equal to 0 and A equal to sigma Y by N, and value of A equal to here 244 divided by 5, it is 48.8, and value of B equal to sigma XY by sigma X square, it is 20 by 10, it is 2. And the required equation of the straight line trend is given by y equal to a plus bx. Okay. Then substitute the value of x, that is each and every year we are finding the salesman, number of salesmen in each and every year. Okay. So this is the way you do all the sums in this exercise. Okay. Practice well. Don't waste your time for your term exam. All the portions are included. Prepare well for your December monthly test also. Okay. Submit your assignment on current time. Thank you, students.